Hi guys, welcome back. In this video I want to talk about how to write the trig functions for any angles. Guys, we have already discussed how to actually measure angles, and then we have also defined trig functions for acute angles in a right angle triangle. Now we are going to extend it to any angles. Guys, it's not too complicated to understand that, but we are going to understand it in context to an XY plane, and then we like to think in terms of a unit circle. In terms of a circle, and then unit circle is a special case of that. And then guys, when we think in terms of a circle or XY coordinate plane, then we're going to have X coordinate, we're going to have Y coordinate, and when we bring in the circle, then we're also going to have the radius of the circle. So guys, let us think about this XY coordinate plane. In an XY coordinate plane, we have, this is my x-axis, this is my y-axis, and then guys, if I have, this is going to be my reference side, we're going to be measuring angles always with respect to this side. We already discussed about that when we talked about how to measure angles. They're always measured with respect to this x-axis, this as a reference side. So guys, let us say I have this terminal side in the first quadrant. So first quadrant, again, it's going to be acute angle. So we have already learned how to find the trig functions for acute angles. So let us understand that, and from there we can just build up and we can talk about how to find or how to write the trig functions for any angles. So if it is in the first quadrant, guys, let us think about this circle, sorry. And in this circle, it almost looks like a circle. It's not an exact precise circle, but let us consider this to be a circle. And then if we think of any point on this unit circle, so let us call this point P, and then the coordinates of this point, since it is in the XY plane, are going to be X and Y. So let's say we don't know the exact value for X and Y, so we're going to just generalize and say it's X and Y. So guys, if I join this line segment from the center to any point on the circumference of the circle, this is also, you can also think of this as the radius of the circle, right? And if I drop a perpendicular from here onto this x-axis, guys, what we get here basically is a right triangle. And so guys, this length is going to be obviously x, right? Because the first value here is x, and then this vertical height is going to be y. And let us call this angle theta, okay? So basically we can think of this as it's just a right triangle, or right, and then this is this theta in this case, because it's in the first quadrant, is going to be an acute angle because it's between 0 and 90. So guys, this can also be thought of as a terminal side, and keep in mind what we are thinking here is that this terminal side is free to go around this circle. So it can be the first, it can be the second, third, or fourth. And once we define it for the first, guys, the same definition is going to hold for any quadrant, okay? And I will tell you what we have to watch out and what is the slight differences between going from one quadrant to the other quadrant. Guys, keep in mind, in the first quadrant, both X and Y values are positive, okay? Keep that in mind. Then things change as we go to the other quadrants. Now let us first define the trig ratios for this first quadrant for this particular setup. So guys, if I have to define the sine and the cosine and the tangent, so let us start with sine. Guys, here I'm only going to define sine, cosine, and tangent. Then the other three are basically the reciprocals of those three, so you can do it on your own. So sine, we know right now from our prior knowledge that sine is opposite over hypotenuse, but in this case we are not calling this opposite, we are calling it y. So it is going to be y over, and the hypotenuse we are thinking in terms of the radius of the circle, so it is y over r. Guys, it is still opposite over hypotenuse, right? Because this is still the opposite side, and this is still the hypotenuse, and this is still the adjacent. But in terms of, we're not now thinking in terms of only opposite and adjacent and hypotenuse, we're thinking in terms of the x coordinates, the y coordinates, and the radius, okay? So that is the first thing, sine. Then the second one, similarly cosine, we know, guys, cosine is the adjacent over hypotenuse, but we don't call adjacent anymore here. We like to think in terms of coordinates, so it's x over, still r is the hypotenuse. And guys, the third one is the tangent of theta. Tangent is, we know tangent is opposite over adjacent, so opposite is y and adjacent is x. So now onwards, guys, I would like you to still remember or still know that it's opposite over hypotenuse and all that, but also bring in or also think in terms of the coordinate plane and in terms of a circle. So when you bring in the coordinate plane and the circle, obviously we will think in terms of the x, y, and the radius r. That's what I would like you guys to now start thinking in terms of, okay? But it is not something different than what we have been doing. It is still opposite and hypotenuse and adjacent, but we are using a new terminology. And I mean, this new terminology is not something new fancy for you guys. You already know the xy coordinate plane, we already know the radius associated with the circle, and then there we have this nice the reference angle. Okay guys, this definition is going to hold true for any angle, whether it's in the first quadrant, second quadrant, third or fourth quadrant. So for example, let me try to use a different color. So guys, if I have this terminal side now in this second quadrant right here, okay, and then the angle, guys, this is going to be the angle. Let us call that angle as theta now, right? Now I'm interested in this point. So guys, again, let us call this point P1, because we already called this P, so I'm going to call this P1. The coordinates are still going to be x and y. We don't know those values, precisely those values for x and y. We're going to say x and y. Guys, keep in mind, in this case now, when I'm thinking of this as a terminal side and this as angle theta, I cannot really create any right triangles here. But guys, the definition is still going to be the same. Sometimes what people like to do, and I also like to do, I would create a right triangle just for making life a little easier for me, for understanding. I would make a right triangle like this, and then I would like to think of this as theta, but this is not exactly theta, guys. That only helps us to solve or simplify things. But in fact, the actual theta is this angle, because theta is always measured with respect to this as the reference side. So this is my actual value, actual theta, okay? And all the definitions are going to be holding true for this particular theta, but they also kind of work well if I think of this as theta. Okay, and when we start doing examples, guys, I'm going to use that, and it will make more sense what I'm actually talking about. Now guys, in this case, the sine, cosine and tangent are still going to be defined the same way. Sine of this theta will still be, so let me call it theta 1 again, so that we can differentiate. Sine of this theta 1, guys, let me write that. Sine of this theta 1 is still going to be what? Y over r. So whatever the value for y is, divided by r. Okay, and r is this radius, okay, which is not going to change once we confine it into a circle. Guys, the key thing that one has to keep in mind here is, when we go in the second quadrant, we have to think, is the y going to be positive or negative? Guys, we know in the first quadrant both x and y are positive, but when we go in the second quadrant, the y is still positive. The y is still positive, but so that means it is still going to be positive, and well, radius is always going to be positive. So when we get the final value, it's going to be a positive value. But guys, here's the difference between this guy in the first quadrant and in the second quadrant, and that is where sometimes students make mistakes. The signs are very critical here. Cosine is defined the same way, adjacent over hypotenuse, but when we think in terms of x and y, it is x over r. But the key thing that one has to keep in mind here when we are in the second quadrant is that x value now is on the left side. That means x will have a negative value. So it will have a negative upstairs and positive downstairs, which will end up giving me a negative value. So cosine of any theta in the second quadrant is going to give me a negative value. That is a key thing that you have to keep in mind. Guys, same thing for the tangent. We know tangent is y over x. Y is still positive in the second quadrant, but x is negative, so you will end up getting a negative value. The other way of thinking about this is the tangent is the ratio of sine over cosine, and if one of them is negative, then you will end up getting a negative as the final answer. So that is the difference, guys. In the first quadrant, everything is positive, x and y is positive, and so all the trig functions are positive. In the second quadrant, guys, cosine and tangent are negative, and only sine is going to be positive. Similarly, if we go to the third quadrant, guys, in the third quadrant, the angle will be like this, measured like this. If we are measuring in a counterclockwise direction, keep in mind we can measure angles in two ways, counterclockwise and clockwise. Now, if I start measuring this clockwise, then I have to measure them as negative angles. So let us call it theta 2. Guys, for this third quadrant, keep in mind the x and y values. Again, we can call this point P2. It will still have coordinates x and y. But the key thing that one has to keep in mind here is that the x is negative. And here the y is also going to be negative. So what does that mean? Wherever we have y and x, those terms are going to be negative. But when we divide y and x, there's a negative upstairs and negative downstairs. It will cross out and you will get a positive value. So in the third quadrant, guys, sine and cosine is negative, tangent is positive. Similarly, we can go in the fourth quadrant, and keeping in mind what are the signs for x and y, guys, we can figure out which is positive and which is negative. So guys, this is how we define the trig ratios for any angles. So we started with an acute angle, but then we did not restrict ourselves only to an acute angle. We went into the second quadrant, so it is more than 90 degrees, then third and fourth. So we are basically able to define it for any angle, okay? Now the only key thing that you have to keep in mind, there's two things. One is the definition that it is going to be opposite or hypotenuse, but in context of this. So what I like to do is, guys, I like to think of this right triangle, and I like to think of this as x, this as y, and this as r. So for reference purposes, guys, I like to draw a triangle, and I know this is opposite if this is my reference angle, but at the same time I know this is same as thinking in terms of a vertical axis, which is y. This is adjacent, but it is also horizontal. That means it is x, and this is my hypotenuse, but I'm thinking in terms of the radius of a circle, then this is the r as well. So guys, this is what I draw for my reference, and then from there I define these things. And the other key thing that I keep in mind, or we have to keep in mind, is the signs. This is in the first quadrant. If we have to draw it in the second quadrant, then the sign is going to change, and third, the sign is going to be different. Same thing with the fourth quadrant, okay? So guys, before we start actually solving problems and examples based on these things, in my next video, I want to just quickly talk about which trig functions are positive and negative in which quadrants, and I want to share with you my technique, my quick and easy technique of remembering it, okay? Till then, guys, take care. I will see you in the next video.